Okay, so let's get started. This is the developer panel. We have 4 panelists here, but the way this really works is that we need questions from the audience. We already have a list of questions here, topics that we're going to discuss, but you can go to this URL and you can add questions anytime during the talk, or if you want, you can get the microphone to ask questions live. And we'll just go through the questions that we get on the Etherpad here. So the URL is etherpad.net/p KVM forum panel. Okay, and we'll start off by introducing the panelists. My name is Stefan Hajnoczi. I work for Red Hat on KVM. And let's just go through one at a time. Dennis, do you want to start?
Yeah, okay. My name is Dennis. I'm looking for
Is it on?
Your mic's on.
Yeah, let's check the mics.
Now it's on. On the top, there's a little switch.
My name is Denis Lunev. I'm working for Virtualization maybe 15 years at the moment.
That's fine.
All right. Not sure how to follow that one. My name is Andy Honig. I lead the virtualization security team at Google. We use KVM for Google Compute Engine, which is our public VM offering, as well as a number of other projects, internal and external. My entire focus is on security. The way I see it, KVM's value proposition is allows you to run untrusted people's code right on your real machines. So that's the number one most important feature to me and my team. My main focus. So main focus is security. First emulator, unfortunately VMware is the best answer I can give, which is sort of sad. But
I'm Daniel Beranger. I've worked for Red Hat for almost 15 years. In the last 10 years or so has been on virtualization, libvirt, Xen, KVM, QEMU, and most bits of the user space stack above that, and most recently OpenStack. First emulator was probably DOSBox or some illegal console emulator.
So I already introduced myself before. My name is Paolo Bonzini. I work for Red Hat. I'm maintainer for KVM and some areas of QEMU. First emulator I used was, of course, a Commodore 64 emulator. I also tried to write my own. It managed to show Commodore Basic V2, and then I lost interest and went back to playing games with the first emulator I used.
Dennis, what about you? Do you want to share what was the first emulator that you ever used?
First emulator I have used was Parallels Desktop.
Okay, cool. So let's start moving on to the topics. And everyone feel free, if you have questions for the panel, to go to this Etherpad and to add them, or to request a mic, and we can just do them live. So the first topic that a lot of people have who come to the conference, especially if you have a team and you want to start contributing and becoming active in the KVM community, in libvirt and QEMU and any of the projects, is contributing to these projects. And we always try to make it easier to contribute. So let's find out, let's talk a little bit about how that's been going over time. How has contributing patches, has it gotten better? Has it gotten easier, worse, since you started contributing? We don't have to go in order. Anyone who feels like they have something to say about this topic can just speak up. Go ahead. What are your thoughts, guys?
I mean, from my point of view, contributing to QEMU, the ease of contribution is just night and day from when I first started 10 years ago. I mean, back in those days, there was Fabrice and all patches went through him. And now with the subsystem maintainer model, it's just far easier to contribute patches and get them accepted and reviewed in a reasonable time. So I'm sure there's room for improvement, but it's working so much better than it used to work in the past.
Okay. So I remember, Dennis, the first time that we met at KVM Forum, I think pretty much the first thing that Dennis said to me was, why are you not merging and reviewing our patches? So do you have any comments?
I think that the situation is a bit twofold. Sending a patch to a popular subsystem is not a big problem. It will be reviewed and accepted. The problem is when you unknown to community and send a patch to a subsystem which is not widely used. In this case, it's very difficult to get the patch merged. Year and a half ago, I have spent a lot of time trying to rewrite unpopular disk format driver in QEMU. It was a real problem to get these patches reviewed because this subsystem was needed only for me and my company. Right now we are working with a more common stuff, and I think that the most important thing that the person could do is to collect personal reputation. With a good reputation, patches are going really faster. So the vote is fair, but it's very difficult to start. If you want to start, you should start from something popular.
So I think, of course, I mean, we are humans, so reputation is certainly a part of it. But I think it's also experience. People should not be discouraged if their submissions get to version 8, version 9, version 10. Like, we maintainers maybe can get things merged only after 2 or 3 versions, maybe even the first time. But rest assured that V1 is the public V1. There were at least 3 or 4 that we threw away before. We've done our own review of our own code a lot before posting, so don't be afraid of iterating a lot on the patches, because that's the same thing that maintainers do, just not publicly, because we wait more maybe before posting the first version. So it's perfectly normal to get more heavy reviews on the first attempts. It's normal that people don't find everything the first time that they look at the code. As the code becomes more complete and as the really low-hanging fruit is fixed, we can get a better picture of the code and we find more needs. So merging things takes time, but if you believe that the maintainers don't want your code, you're wrong. We really want your code, and we're not trying to make it harder for you. Believe me.
Well, I'll just point out, I think that's gotten better over time. I think earlier and under previous maintainers, there's a lot of times where you send a patch and you get crickets and nobody even wants to review it or look at it. And I think Paolo's done a good job of being much more proactive in reviewing every patch, even ones that seem a little zany at first.
I think that we could discuss the contract in between submitters and maintainers. The main problem is not the amount of iteration. The main problem is the latency in between iterations, when we have sent a patch and there is no answer. Maybe it would be good if patch series will be smaller, and on the other hand, maintainers will respond with less timeout.
What do you think?
Yeah, so actually what I was going to move on to is we have a follow-up question that's related to some of these things. And for example, from what you just said before, Dennis, it seems like there are certain techniques that you can use, some approaches that you can take to make it easier to get your stuff accepted. Like you said, start contributing to something that's well-maintained and popular, because if you send a big feature in a new area that no one reviews and works on, it's going to be hard to get it merged because people won't be confident. There'll be no one there who knows you. There'll be no one there who understands that area. And so what approaches have you guys found besides that help?
I mean, I think starting with bug fixes always gets people's attention. It shows that you understand the code, and almost no one will refuse a bug fix if it actually fixes a bug. And that's a good way to sort of build up reputation as someone who knows the code.
I think it's also, I mean, it's true of pretty much every open source project I've worked on, is that there's always more patches than there is reviewer time. So I think people who are contributing to QEMU shouldn't think that maintainers are the only people who should be reviewing. Anyone who's on the QEMU mailing list should feel free to review patches that are sent there if they think they understand that area of code. So that just helps spread the review burden across more people and also demonstrates your own ability as someone who understands the code. So that helps build your reputation as a new contributor.
Yeah. I mean, I remember in the early days when I started contributing, someone, I noticed that my patches weren't getting reviewed as quickly or merged as quickly as possible. And someone told me, why don't you go and ask the maintainer what you can do to help them? Because obviously they're busy and they don't have time to review your patches. And so I did that, and they basically asked me to help and start reviewing the other patches that are in their review queue. And so I was able to make their life easier. So I think that helped get my code upstream quicker as well. So there's a question here that I think Paulo, who just did the keynote, can probably answer. How healthy is the contributor base to QEMU? So you showed some of the stats on KVM. You showed the contributions. How are we doing for QEMU?
So I would have probably to defer to Alex, who's giving the same kind of talk this afternoon. This afternoon, I think.
Tomorrow morning.
Oh, tomorrow morning?
It's the libvirt this afternoon.
I can talk in general about KVM, QEMU, and libvirt together. I think it's healthy. It varies. So Red Hat generally has the majority of the commits throughout the stack. It varies from about 30% for KVM because of the reason as I mentioned before, to 60% for QEMU and around 80-85 for libvirt. But on the other hand, we have stable contributors from other companies throughout the stack. We have a long tail of people. I think we appreciate the efforts of people that drive by, leave a patch, and almost all of them sooner or later do return. So maybe we have one patch every year from some person, but you can see that really a lot of contributors, even the not so frequent one, are returning and care about helping. And another question is the one just below. So how healthy is the maintainer base for QEMU? And are the unmaintained sections of QEMU an issue, and how do we improve the situation? I don't have an answer for this. The only thing I know is that the unmaintained sections of QEMU have a pretty good defect rate in Coverity. That's just a data point, but at least it shows that the important code that we care about sometimes is in worse shape. Because that's obvious because it's complicated. Most of the unmaintained sections of QEMU are really simple. Most of them you can even compile out. So they are not an issue. To improve the situation, just ask to become a maintainer for them. I mean, the overall defect rate for QEMU in Coverity is really low. It's like 0.07 defects for every 10,000 lines of code. And for the unmaintained sections, it's 0.03. So both of them are really low, but it's even lower for the parts that are not maintained, mostly because it's simpler code than the others.
Okay, we do have some other topics that we're going to move on to, but we can definitely still do one of these questions. There is one here lamenting kind of the state of documentation in QEMU. A lot of people who start contributing to QEMU realize that the code is the documentation because we don't have that much internals documentation for QEMU. So it can be hard for new contributors because you basically just have to read a lot of the code in order to figure out how things work. Are there any things that we should be doing to improve this, or is that just the nature of it? For example, the Linux kernel does have more documentation for people who want to write new drivers. It's a little bit easier to get into. Any thoughts?
Yeah, we need more docs. No, but I mean, we did have a discussion about this in the QEMU maintainers summit yesterday, and there's various things that we could be doing better. For internal stuff, we could be doing more formal internal API documentation and actually generating that into documentation pages you can actually read. We could have better general internal architecture concept documentation, whether that's in tree or on the wiki. We talked about pulling together the kind of up-to-date presentations people have done on various topics. So a lot of the sessions here, well, all of the sessions here are being recorded, and a lot of those give useful information about the state of the internals. And if we can encourage maintainers or people submitting new features to actually write up their new feature in a blog post or in a wiki feature page, that all helps. So there's a lot more we could be doing and encouraging maintainers to be doing.
Okay, yeah. And so there are always, there have been KVM forum presentations, and there continue to be KVM forum presentations that give a good overview. There's been presentations about writing new block drivers. There's been presentations about how does TCG work if you want to implement maybe a new architecture, for example. But we don't have good single source of documentation. We can come back to this at the end if we have time, but let's move on. We have a few other topics. The next big one is security. We've already heard, for example, that nested virtualization. There's been a recent security push. But in general, how satisfied are you with the state of security and what has happened in the past year, the CVEs? Is the code quality okay? Are we heading in the right direction?
I guess I'll take this one. I'm pretty satisfied with it. I think when I see that graph and the number of commits go up, it certainly makes me nervous. I feel like the speed of development has increased, and I don't know that the speed of sort of security review. One of the things that Paolo brought up in his keynote a couple years ago that I didn't see today was how many patches were reviewed by someone other than the maintainer. And a couple years ago, that seemed to be going up, and I think that's going down again, which I think is bad for security. So, I wouldn't say, I'm not sure if satisfied is the right word, but I think it's not terrible. We use it at Google. Obviously, we have some confidence in it.
Okay, well I think there's a follow-up question to that.
Sorry.
Okay, go ahead, Dennis.
I have one side note. Both recent security updates have broken my pattern of work. VGA security has broken Windows 20.08, and recent update with Virtualization has also broken suspend resume. So we should maybe pay more attention on testing of that stuff. Something like that. Yes, it's good that security is released in time, but maybe it should be better tested.
Okay, yeah. Okay, so given the security work that has happened in QEMU, especially I know the Google team has been focusing on, not QEMU, on KVM, kernel module, on all the auditing, how has that changed over time? Because you've used fuzzers, I guess you've done manual auditing, and probably the types of bugs that you find and you still expect to lurk out there must have changed because you've gotten the low-hanging fruit. So what's the state of the bugs that are still on your mind?
Sure. I mean, there's definitely still the microarchitectural side channels, which are always an issue, and you can't really stamp those out. And sort of the row hammer type problems. For anyone who doesn't know, row hammer is an attack where you do read operations and drains power from the DRAM line and flips bits in a nearby line. Things like that certainly worry us today. In terms of KVM, we actually feel pretty good about where we're at with the features we use, and we only write new fuzzers when you guys write new features, and that's usually when we find new bugs. We kind of, I think we've found all of the even low and medium hanging fruit anywhere near the things we use, and as you guys add more stuff, we go looking harder.
Paulo, do you have any thoughts as KVM maintainer about security of KVM?
No, yeah, I mean, I already mentioned nested virtualization, and the work, the very fact that work has started on securing nested virtualization means that the low and medium hanging fruit is basically done, because it's a completely new part of the code to focus on, and it's, by our own admission, never been written with too much with security in mind. They found time of check, time of use bugs. They found really stuff that we expected to be there, but on the other hand, maybe shouldn't be there. I mean, if the code is considered secure. So I think it's exciting to move to this kind of more complicated features, because they are going to be used more and more in the future, and I'm very happy that we're finally attacking it, and maybe next year I can say that we are enabling nested virtualization by default. I wouldn't do that today, but maybe next year we could.
Okay.
I mean, there's a lot of focus on security is on obviously the guest attack surface, but I think what's been largely ignored is the management host side. For example, I can't believe we've gone for 10 plus years without having encryption of migration, for example. There's just been this kind of assumption that the internal hosting network is secure, and I think in the modern world it's pretty clear that internal networks have to be considered as insecure as the internet, and so that's part of the motivation for the work I've been doing over the past year, is to try and give some credible security to the host management side and the network interactions there.
All right, thanks, Dan. So another interesting security thing, which is more of a future feature, is that new hardware features are adding memory encryption support and secure enclaves. And basically, they may be able to get us to this holy grail of, if you have a hosting provider or a cloud, that cloud cannot actually reach into a VM. So what do you guys think? Is that something that we'll be able to achieve in KVM with memory encryption and the Intel SGX kind of stuff heading in that direction?
So I'll give my opinion. I think the AMD memory encryption is a nice feature. I think it has some security benefits. As designed now, and I'm interested to talk later, I don't see it taking the hypervisor out of the trust boundary the way it's designed. But I do see that in Intel SGX. But Intel SGX just seems so restrictive. It's going to be interesting if you could actually do something interesting in there. So I think my team is certainly excited about it, and we're experimenting with it, and we're playing with it, and we hope we get there. But
yeah, I agree. So for the AMD feature, the main part that it doesn't cover is all the side channels. The hypervisor can still leak a lot from the guests through side channels, from registers, hardware breakpoints, page faults. So I don't think that, at least as it's currently designed, it can protect from a malicious hypervisor, and I think the AMD guys totally admit that. But it's a very good feature for protecting from malicious guest. So you don't have to be worried of being on the same host as someone nasty.
But I think that this will come at a price, because in this case we will have page sharing disabled, and this page sharing disabled, we will also will get lost a serious subchannel to leak information within the guest from other guests. And the raw hammer will not be an issue.
Okay.
And another benefit of memory encryption is that it heavily makes it much harder to exploit the bit flipping attacks that he mentioned before, because you flip one bit and everything changes. You maybe can still do things like hoping that the RSA primes are not prime by flipping bits, but not much more.
Okay. We have another topic, and that's lightweight VMs and containers. Obviously, containers have become very popular, and they've caused people to re-examine virtual machines to see what we can do to make virtual machines boot faster, have a lighter footprint, so that it becomes possible to get more density, but also to use this kind of container workflow with layered images, and maybe kind of the Docker style, just running an application, but running it inside a VM, so you have the full isolation. And work has been done on this for the past year or two, definitely. So we have a couple of questions in this area. And maybe actually this is a good one to start with, the one that came from the audience. How fast do you need a VM to start up? And I was a little bit involved in some of the work that has gone on optimizing lightweight VMs. And our target for QEMU, from launching the QEMU command to getting to the kernel entry inside the guest, was 40 milliseconds, and that was achieved. But it's not upstream. It did require, optimizations that are, build time, and were quite aggressive. So over time, I guess the goal is to always have that 40 milliseconds, even with a mainline QEMU, the binary you would get from your Linux distro. Any other comments on the speed of booting up, starting a new VM?
I think that we should think not only about booting up, clear booting up, because it will be not that fast, but maybe we should think about faster snapshot when in light VM case, the VM will be able to boot, not to boot, but to resume in those 30 milliseconds.
Yeah, I agree with that. I mean, the 40 millisecond timer doesn't really matter if it takes the OS 15 seconds to boot.
Yes, that's right.
I mean, I think it entirely depends on what you're doing with the guest OS. I mean, if there's something, if booting the guest is in the critical path of responding to some request, and that request has to be served in a timely manner, then obviously the shorter startup time is important. But if the process of booting the guest is not in the critical path, then the time is not so important. It could be 1 second, 2 seconds, but not necessarily 30 seconds. And also, I think it's important to know if you're comparing this with say Docker, then you're not actually going to be running a full OS inside this virtual machine. You're going to be starting KVM, boots the Linux kernel, and then immediately executes your desired application. There's no init system to start up 30 different services. You just start your application directly. So you eliminate that OS startup time. I think it's important to remember that there's nothing inherent about virtual machines which say you have to run a full OS. They're perfectly capable of running single applications, just as containers are. And containers can run full OSs just like virtual machines can. They can both serve the same use cases, really.
Okay, and by the way, if there are any questions from the audience, feel free to. We do have a mic, so you can ask questions and participate. So half of the whole lightweight VM thing is making sure that you can start VMs quickly, but the other half and harder problem is the memory management, because when you have a virtual machine, you give it a block of memory, and that's its physical memory. That's the guest physical memory. And of course, if you compare that to processes are much more flexible. Processes running on the host kernel, and so are containers. So one of the big challenges is what new memory management things beside VirtIO Balloon do we have to do in order to make lightweight VMs as flexible as containers?
I think that the question is not about balloon at all. The question is that the host kernel knows how to manage this exact page of RAM. It knows that it have VMware backing or it can just drop it. It knows that this page is hot or not. If the page is inside VM, the host kernel doesn't know all this stuff. He just could put the page to the swap. And if the kernel put page cache page to the swap, we will not get anything good with this approach. Fortunately, LightVM has reduced the amount of page cache pages in the guest using execute in place. But the data pages, when the guest is working with its own files, will still be in page cache and something like that. This problem should be somehow addressed and resolved. In this case, LightVM will really work like containers.
So I think that the cooperative guest host memory management isn't exactly the right way to put it. If you have this kind of microservice architectures where VM run for 300 milliseconds, they don't even have time to manage memory. So the point is not really to get cooperative for this kind of architecture, but just to leave memory management to the host. So stuff like execute in place is good because, or DEX, how it's called in Linux, is good because you just use the host page cache. There's no memory management to do at all, basically, in the guest. So the cooperative memory management with ballooning is suitable for longer lived VMs. It's suitable if you run containers inside the VM. If you go for lightweight VMs, I think it's a completely different problem domain. And as you said, it's harder, and it's harder also because it's new and different.
I think that LightVM can be used for full operating system containers which will live more than 100 milliseconds. And this would be good, because this pattern is also needed. So some memory management is a good idea.
Yeah.
I think just slightly off topic, but I think one thing that's missed in talking about the lightweight VMs is just in terms of performance, you're going to want these lightweight VMs using KVM. And a lot of these container-based workloads, the container management software is running inside a VM already. So if you want to replace this usage of containers with usage of lightweight VMs, you kind of inherently need nested virtualization if you want to swap out like for like in their current deployment environments. So the work on improving security of nested virtualization, I think, is pretty key to making use of lightweight VMs viable in the general case.
Well, that's good for the next topic, because the next topic is nested virtualization. Nested virtualization has been around for a while, but it hasn't been heavily used, and it's not really kind of a production feature, at least for most people. And so I guess the question is, now that there's this security discussion about nested virt, the other discussion has to be what else is on the to-do list? What needs to be done in order to make it production ready?
One big deal is that there are many different SKUs that you can buy from Intel or AMD, and they have different virtualization features. Some have APIC-V, some don't have, some maybe it's just that you have older processors in the data center that date back to before the introduction of APIC-V and other virtualization features. Currently, we don't have any way to disable or enable features in the guest. Something like the CPU models that I mentioned for ST90 before. And this is not a 100% necessary feature, but it does make management life much easier for management software. So it's not an easy problem to solve because of the wide variety of processors that are around, and it's not really well documented which processors have which CPU features. That's only accessible from MSRs, not with the CPU ID, so user space cannot easily figure out what are the available virtualization features. On the other hand, it's a problem that we solved for CPU ID, and it's roughly the same domain. But I think it's an important thing to have for production. In some scenarios. Other people never migrate VMs, don't care, but...
we have that, and some does.
Okay, well, if there are no more thoughts on nested virtualization, then...
May I say one thing?
Go ahead, then.
I think that one of the most important problem is a problem of heterogeneous environment when we have one hypervisor in host, which is KVM, and yet another hypervisor in guest, like Hyper-V. I do think that this will be a problem because it requires a lot of knowledge to test Hyper-V server feature inside the guest. I think that we, as a community working with Linux, lacks expertise in this area, something like that.
Okay, thanks, Pandan. So in case anyone didn't hear because of the microphone, I think I don't really understand the internals of nested virt. I've never looked at it, but it sounded like the problem is that with nested virt, you've got not just KVM, but you could have any hypervisor underneath. And in fact, these hypervisors, in order for make nesting work, they don't all make the same assumptions or provide the same environment. So yeah, so there's probably going to be integration challenges.
I think that's not that different than how KVM got started because, you know, you could say the same thing about OSs because KVM isn't a perfect x86 system emulator. And it was broken, and I've broken OSs I've never heard of before with patches and then had to fix that. So I think that's just one of those things that we'll get better at with time and experimentation.
I want to point out a kind of a conflict of interest between what the previous commenter said and a comment Paulo recently made, which is about, are we trying to emulate a particular CPU that was shipped, or do we want to emulate all of the features that somebody would like to have? And these are often in conflict. So you may find that the features that KVM requires from the L0 hypervisor in order to afford L1 certain virtualization features are dictated by what kind of chip you would have ever actually seen in the wild. So for example, if you had EPT, then you would have also had the kind of invalidation that you described. One other comment about testing different guests or different payloads. This is a comment about nesting, but testing in general. The philosophy that we've started adopting, kind of along the lines of KVM unit tests, is not so much to test, does Hyper-V work or does ESX work or does KVM work, but is this a VTX implementation? So testing for architectural conformance rather than kind of special cases and making sure you didn't screw up. And you can apply this as well, or this philosophy, to just seeing if you're doing virtualization properly. And that's, I think, KVM has it's a sore need or a benefit from nurturing in this area.
Okay, so we've reached the end. I just do want to go out with a bang. Someone here posted thoughts on replacing code reviews on the mailing list with Gerrit. And I think that's really easy to answer. Guys, what do you think?
Hell no.
I mean, I think we need to do more work on continuous integration. We now have started automatic coding style reviews for QEMU, but no.
But I mean, more seriously, I think there are some good things about Gerrit. The thing that I think people find really compelling is that it actually tracks every patch that's submitted, and you can see the status of every patch. That kind of status often gets lost in the long threads of emails. But just from the point of view of actually doing the code reviews, it's really, really painful, particularly for patch series. And QEMU has a lot of big patch series that just wouldn't be well suited to Gerrit.
Can I ask a question? What tool do you use to do code review? I mean, I assume you're not reading the email.
Yeah,
you're just reading the email and looking at code?
It's the basic workflow, yeah.
You can even have two monitors, one with a terminal and one with a terminal running math.
Yeah. I mean, so one of my, I'll just sort of state the unpopular opinion for a minute. One of the things that I don't like about the kernel's email review style is that it really encourages you to just look at the small patch and its impact. And I think, if you look at security bugs, which is really the only thing I really care about, a lot of those are because it looked good here, but it had some interaction that you didn't realize somewhere else. And when I'm trying to review like the recent break the APIC barrier bug, sort of going back and forth, I just had to essentially download it all, merge it all, and then review everything from there to get any sort of good feeling from the security. So I think that makes it harder than the current way it's done. Okay. Not that Gerrit would fix that problem. But,
yeah. I think that there are 2 points here. First point is how review is performed. Usually you write review is performed, I save patches to file system, I apply them, I read them, third, and write an answer. And another question is about tracking, that the patch which has been sent will be reviewed in some time. So maybe if we are speaking about the review process, the tool is not the purpose to perform actual review. It's doing by maintainers, and maintainers doing this well. Maybe it's a matter of tracking of what should be done. So there are other tools like Patchwork or something like that.
Okay, unfortunately we need to end there, but thank you everyone.